morning, students. Today we are going to discuss about waterfall model in practice. What is waterfall model? Waterfall model is a sequential model or step-by-step design model. In this model, the software project is going to be developed or built in sequential pattern, phase by phase. Okay. During waterfall model, the following problems is going to be identified. The following symptoms are going to be exhibited. Sometimes these are called drawbacks of the waterfall model. There are 5 basic drawbacks are there in the waterfall model. First one is protracted integration and late design breakage. Second one is late risk resolution. Third one is requirements driven functional decomposition. Fourth one is advisory stakeholder relationships. Last one is focus on documents and review meetings. These 5 points known as symptoms of the waterfall model or drawbacks of the waterfall model. These problems we need to overcome during software development. Right. First one, protracted integration and late design. What is protracted integration? Protracted means the integration phase takes more time. Protracted means long duration. The word protracted means long duration. For integration phase, during integration phase, all components, whatever the components, we want to make them as single project. For that it takes more time. Most of the project time is spent on integration, and the late design breakage, even design phase also takes more time, and some problems will arise during project design. That's why the waterfall model becomes failure or problems arises during this activity. To overcome all these problems, we should follow the following steps. Early paper design through briefings. If as possible as we should make some paper design and briefings. Briefings are nothing but discussions. Commitment to code very late in cycle. The coding part becomes late because most of the project time spent in the integration and as well as design phase. So finally the coding phase will get only limited time, right? Third one, integration nightmares due to unforeseen implementation and interface issues. Integration nightmares. The integration activity doesn't know whether it is going to become success or not. The actual focus, the main focus, you don't know where to spend much time on the integration, right? So next one, heavy budget and schedule pressure to get the system working, because this is very important point. We have to remember that during waterfall model, the actual schedule is limited. For each and every phase, some amount of time is going to be fixed. Within that schedule, the activity has to be finished. But coming to integration phase, it takes more time. Most of the project run in the integration phase. The components have to be integrated one by one. For that, it takes a lot of time. So even budget and schedule will also cross. Budget means cost. Schedule is the time. Schedule and budget both will cross the actual budget and schedule provided in the starting phase. Okay. Next, late shoehorning non-optimal fixes, and a very fragile, unmaintained product will be delivered at the end. These are the main problems exhibit during waterfall model. If we control all the problems systematically, definitely the product is going to be delivered. But it is not possible all the cases the product is going to be delivered within the schedule or budget. So finally, what happens? The time exceeds exceeded, automatically unmaintainable product will be delivered to the client. The client definitely not able to use the finished product. So see this diagram. So in this diagram, you will understood the progress of the conventional software project, how the project will run from starting phase to ending phase. So if you see in the diagram, sequential activities: one, requirements, design, coding, integration, testing. Arrow is given. Just to follow the arrow activities. First activity is called requirements. Second one is design, coding, integration, testing. Requirements already I told you in the previous class. Requirements are nothing but sub problems. All the problems have to be designed. That is called architecture. Then we have to make coding. Then integration, testing. See, in the following diagram, in x-axis, project schedule is mentioned. Schedule means time. There are 4 schedules: 1, 2, 3, 4. Original target date is third one. During that target date, the product has to be released. The product has to be finished. See, the amount of work completed is mentioned on y-axis. Development progress, that's the coding activity. And see, in the circle, some curves are there, up and down curves. It's called late design breakage. The design part takes more time. Architecture part will take more time. That's why the ups and problems are going to arise here. The architecture team doesn't know how to make good architecture. He doesn't know the actual requirements and its limitations. That's why the product becomes more delay. The, the delay is the main reason in the waterfall model. All problems will be identified at the end. So it is not possible to rectify the problems which are arise at the end of the phase. See, in this slide also I mentioned format, activity, product. Activity, first activity is requirements analysis, and all the requirements you have to take ad hoc text. You have written on the document. All the requirements you have to note down. Requirements are called sub-problems. Problems are identified. Each and every problem is mentioned in the format called ad hoc text. It's a written text is called document. Second stage is program design, architecture design. Architecture design means algorithm or database design put on the paper. They will put on the document. This is called document. The method format is called flowcharts or algorithms or UML diagrams, whatever it is. The design methods. And third one is coding and unit testing. Coding means source program writing, unit testing. Format is source code, programming steps. Source code is called programming steps, step by step instructions, coded units. And last one is protracted integration and testing is done at end. Configuration baseline, phrasing baseline. Phrasing, a delicate system is to be produced. Okay, these are 4 phases. The overall project is going to built in 4 stages. Stage 1, requirements analysis, and the product outcome is called document. Second stage, program design, it's called architecture. The product is called documents. Third stage is coding and unit testing, is called coded units, programs, source code like programs. And last one is protracted integration testing. Protracted integration means it takes more time on integration. Integration means combining all modules. Com- Combining all modules together is called integration. And testing. Testing is done after finishing the integration. The overall product has to be tested. And fragile baseline. Baseline means already we gathered all the requirements. As per the requirements, the business system has to be built. So this is the phase-wise conventional software development. Next, um, each activity and the cost is mentioned in the following slide. The management activity takes 5% of the overall project. Requirements is 5%. Design, architecture design is 10% of the overall project cost. Code and unit testing takes 30%. Integration testing takes 40% of cost. So most of the cost included spent on integration and testing. Deployment, delivery is 5 and environment is 5%. Total is 100%. So this is the cost activity of the waterfall model. Second one, late risk resolution. Late risk resolution. So why the software product becomes risk? Why the project enter into the risk? The product is going to be the product is going to enter into the risk because of the following four reasons. First reason is probability of missing cost. The exact cost is going to be estimated wrong. Exact cost cannot be estimated properly. And second one is schedule, time. Third one is feature, quality. If we miss the four, definitely the project enter the risk. Definitely the project is going to become a risk. Probability of missing cost. So based on the project size, the development team or project manager has to identify the overall cost. If they do mistake in this step, definitely the software company has to face a lot of risks. Second one is schedule. Schedule means the overall progress of the project is to be split into different schedules, like slots. First 1 month what to be developed, in second month what to be finished, third month, like that. The project is divided into different schedules. In each schedule, the amount of work which is specified to be completed. A feature means the technology and components, everything should be identified clearly. And quality goal. Quality comes only through proper control and monitoring by the software management. Risk profile of the conventional software process model is given in the following life cycle. As already mentioned in the previous slide, the conventional system, the software project is going to be built in 4 stages. Stage 1, requirements. Stage 2, design coding. Stage 3, integration and testing. See, the project life cycle. The risk exploration period, all the risk is high during requirements. So we don't know exactly how to implement the risk, uh, risks. So this factor is high during requirements. Then design coding also same. Then integration, last testing during that time. Almost all risks are identified clearly. Okay. Requirements driven functional decomposition. As I told in the previous slide, the project development comes through in 4 phases. First one is requirements, second is software requirements, software components, software units. Requirements R1, R2, and so on, Rn. These are set of requirements. these requirements are broken or divided into next level of sub problems, R1, R2, and so on, like that. So it will be divided like functional coding units. Step 1 requirement, then sub requirements, then designing of the requirement, then actual coding will be done at the end part of the program. If you design like that, so the risks are going to be minimized. Fourth one, advisory stakeholder relationships. Here, stakeholders are nothing but clients. So for large scale software company, they have to maintain good relationships with the stakeholders. But the stakeholders sometimes they may not satisfy with the development of the software product. To satisfy all the stakeholders, they have to follow customer satisfaction. Win-win strategy condition they have to follow. Win-win strategy means frequently the development team should approach with the stakeholders, and they need to take feedback from the customers. So it's a in stage wise we need to get approval from the customers called stakeholders. The development company, if they finish 25% of work, whatever they finish, they have to show, they have to explain to the stakeholders. If they satisfied, then the company has to move further level so that you can eliminate the problems which are coming in the future by the stakeholders that are going to be minimized. So as I mentioned, see, the customer was expected to provide comments typically within 15 to 30 days. Within 1 month, whatever the amount of work completed, that has to be explained or shown to the stakeholders so that they will feel some satisfaction, and they will give some suggestions also if they want to explain. Focus on documents and review meetings as possible as meetings and some briefing things should be provided. So it is nothing but providing a necessary debate or review or called work progress with the development teams so that the remaining people will follow easily one big briefing to uh, diverse audience, a design that appears to be compliant. Coverage of requirements typically hundreds. A design consider innocent until proven guilty. So all these provides results of conventional software project design reviews. Okay, right. So next class will follow software economics. Software economics are five: size, process, personnel, environment, and quality. This is very important. Software economics are related to main how the software project is going to be built, how the software project is to be managed. It purely depends upon five important software economics. These five are very important. We will discuss in the next class.